We'll probably get started pretty close to on time, just because, again, I know it's late for some of you, especially if you're on the East Coast. And folks can watch the recording if they miss a little bit of the meeting as well. So I'll get started in about 2 minutes. We'll give people 2 more minutes to join. In the meantime, if you do have a short question we can address in the chat, feel free to throw it in there, something short. We probably can't address anything too lengthy. Wait a couple of minutes. Hi, Susan. Who's here? Oh, I looked down the list. Not too many. We had a lot of folks at the first one, but not too many on this one. So,
Hi there.
hi, Susan. Okay, 1 more minute and I'll get started. Excuse me. Okie dokie. Okay, I'm gonna go ahead and get started. Just so I know who is here in person, so I have an idea. If you guys can that are here, go ahead and throw in the chat just where you are located. So where you're mentoring a team from. Because we're going to talk a little bit about some specifics in terms of in-person events or virtual events. So it's kind of helpful to know where people are at.
Darcy, we can only text to you or Deanna.
Oh, that's okay. I'll see it. So go ahead and put it in there anyways. So I'll call it out. We got someone from Waretown, New Jersey, Shelby, Kentucky. Shelbyville, sorry, I don't know why I cut that name off. And let's see. Go ahead and throw that in there. I'm looking at it. I'm going to keep going here. So everybody, welcome to the Artemis Roads 2 Mission Advisor Support Session 2, the second version. We use these support sessions to help our mission advisors along the way, along the challenge, and also just give you guys an opportunity to come join us and ask your questions as you have them. Hopefully everyone now is underway with their students and doing the challenge. So you guys have your feet wet with some of the mission objectives, which is a good thing, but can also, again, bring up some challenges. So we're here to help as we go through the challenge. So before I get started, I'll introduce myself. If you have not met me yet, I'm Dr. Darcy Snowden. I'm the director and principal investigator of the Northwest Earth and Space Sciences Pathways, which is the organization running the challenge. I'm a physics professor here at Central Washington University in Ellensburg, Washington. Joining me is Deanna Marshall. Say hello. You can see her. Hopefully she's got her videos on and you guys have probably already communicated with her via email. She's our awesome program manager. So she's running the program. And if you send an email to info@NSB, you're most likely to either get a phone call or an email response from her. And then I don't know if Anita is here. She might not be here with us, but you also, as you go through the challenge, should be interacting with Anita Mashana. She's our office assistant, who was also working at Central Washington University. And then I'll just introduce one more person if she wants to throw her camera on. Susan Stoffer is also joining us. She just had her camera on. So we'll be talking about her in a bit, but she's our Idaho in-person event coordinator. So she also helps us with the challenge and specifically is helping the teams in the Idaho region and Upper Utah, basically teams that are close to her in her part of the country. Okay. So today what we're going to talk about is we're going to go over again. We did this last time, but in a little bit more detail for those of you guys that are able to go to an in-person challenge event, the dates and locations and some of the details about that. And then how to register. So there's another submission form open. So we'll go through that. Briefly, what it means if you can't attend an in-person event. This is the national challenge, and we don't have, unfortunately, enough capacity to offer in-person events throughout the country. And then at the very end, I'm going to help you guys out with a couple of the harder mission objectives. So we'll talk about the rover and the rocket mission objectives. Okay, so I'm just going to quickly look through the list here. see where people are from. I don't think everybody completed the assignment. We got South Carolina, Arizona, and a Washington team. Okay, so that does help because I'll be able to either breeze through the in-person stuff or spend a little bit more time on it. Okay, so let's get started. Oh, actually, before I get started, I did want to remind you guys, if you haven't taken a look already, so if you guys filled out the ignition or injection burn submission form, you should have submitted your team's mission patch along with your student team information. So this is just a fun video scrolling through some of the mission patches we've posted so far. We haven't posted all of them yet. We're going to be posting these. We have so many for weeks. Okay. So if you can, sign on to our social media. It's Facebook, Instagram, and Twitter at NESB. And go ahead and check out some of the other teams' mission patches and give them a like. I think they will appreciate that. I also wanted to talk a little bit about this item that came up in the news, actually about the same time that we were preparing to start posting these mission patches. And Jeremy Hansen is one of the Artemis 2 astronauts that's going to fly in the Artemis 2 mission, whose job is to basically go back to the moon, orbit around the moon, and then return to Earth. And he did something really cool and unique. He collaborated with, I'm going to probably mess up their names, but Henry Gunman from the Anishinaabe tribe, and David Cochran III, who's the leader of the Turtle Lodge at the Sag King First Nation. These are First Nation tribes in Canada, and they helped him come up with this culturally relevant to their area mission patch that he's going to wear on his uniform during the Artemis 2 mission. So if you did this activity with your students, and in particular, if you took advantage of the opportunity to help them make the mission patch that is really representative of them and their community and where they live, might be fun to show them this mission patch and talk a little bit about how they were able to incorporate some culturally relevant items in here. And just to give you one more resource for that, I'm not going to play this whole video. You guys can find it on YouTube, but I'll just play a little bit of it. And this is something that you can play for your students. Go to the part that I wanted to show here. And again, this is on YouTube, and it basically has the designers of this mission patch going through it element by element and talking about why they included those parts of the mission patch or those elements in the mission patch. So I'll just play a little bit of this video.
Everything I thought it would be. It's amazing, Henry. It's just absolutely beautiful work. Would you mind maybe telling us a little bit about what you decided to include in here and why?
Well, the bowl represents in Greek mythology Artemis, and she's going to launch her arrow, and the astronaut's going to be riding on that arrow, going to the moon. And then we have the dipper, and the star represents you and your family. This blue represents all spirits of mankind. The silver will represent the capsule that you'll be in.
And the Spirit will be with us inside the capsule.
And we have the 7 teachings. And these symbols represent the flowing Spirit.
Okay, there's more good stuff in this video, but I'll end it there. But again, looking at the students' mission patches, a lot of them look similar to that. They incorporated animals and colors that they liked or colors that they thought were related to the mission. And it's just another good time to talk about, hey, like when NASA decides to send not just robots to space, but people to space, we're really sending humanity to space, and we are increasing the sphere of influence of humanity. So we have to make sure that we are taking everybody with us and not just taking the few people that actually get to go on the spacecraft. And one way we can do that is by making these mission patches that represent whole communities or civilizations.
Excuse me, Darcy.
Yeah.
are showing, there you go. We just switched over to your presentation. We just had the other screen up, so, okay.
You could see the video, right? I didn't just talk
We
over
watched,
nothing.
no, we've got the video. That was good.
Okay, woo! That would have been really bad. Okay, great. Okay, last thing I want to remind you guys of, we'll do this quick. There is the next NASA expert talk has been scheduled. And we're going to be listening or hearing from Dr. Ernest Lewis, who is a principal scientist and a founder of Pearl Lab. And he does a lot of really cool stuff in outreach. So he's going to be talking about, he's a chemist. So he's going to talk about from a chemistry perspective, how he thinks about the interaction of surfaces of planets and the stuff we might be sending there, like boots and wheels and things like that. So please join us for that. It'll be a short presentation and then lots of time for questions. And last time the students had a lot of great questions. So looking forward to that. Okay, so dates and locations of in-person challenge events. These slides that I'm about to show are available to you guys on the website already. I'm going to go through them very quickly because there's a lot of text on them. And again, you guys can review them later. But just want to remind you guys that once your students, as they're going through the challenge, we do like to have a culminating kind of event at the end. And one of the options, if you're near one of these in-person challenge events, is to come in person and complete some of the elements of the challenge in front of us, in front of other students that are doing the challenge. And also, so it's the launch phase, which is the water bottle rocket mission objective, and the surface navigation phase, which is the rover mission objective. But we also ask them to present any other mission objectives that they chose to do. So all of this is described in M08 if you're choosing to go to an in-person event. So take a look at that, and that will help you prepare your team for the event. In general, the events are all one-day events. Some of them have some optional activities. There's teams that are staying overnight, and I'll talk about that. And everything varies by location. So let's go through each location quickly. I'll skip that slide. Okay, so there is an in-person event in Texas, and this is facilitated by actually NESB's Science Activation, NASA Science Activation partner, SEAS, at the University of Texas at Austin. And these ladies, Pierre, Margaret, and Selena, are awesome. They do a lot of these kinds of events for students. And so their event is going to be on June 3rd. So not for a while. So you got lots of time to prepare. And it's during the day. So from 9 to 3 p.m. And it is going to be on the University of Texas at Austin campus. If you are far from Austin, and many Texas teams are, we do this group is offering travel support. They have their way of doing it. So they will be inviting teams by May 11th. And when they invite you, they will offer the travel support that they have available for your team at that time. And it will be a hotel accommodation. Okay. Again, these slides are available to you. If you have specific questions about this event, you can contact the Selena or Margaret, whose email is on this slide. Montana is happening on May 21st, so sooner. And that's actually a Tuesday. So it's something kind of unique. They talk to the teachers in their region and they preferred a weekday. It's going to be on Montana State University. And again, lots of teams are traveling far because they're spread out across Montana. So there will be travel support and in particular hotel rooms for teams traveling 2 hours or more so that you don't have to get up too early to get to the event. And the contact for that event is Camden Drager, and his email is there. They're going to be contacting teams after the March 15th deadline for registration, which I'll talk about in a bit. Washington, Oregon, that's us here at Central. So Deanna and Anita are organizing this event right now. The main event's on May 4th, but for teams that are coming overnight, we have a few activities on May 3rd that are optional on campus. And this is at Central Washington University, which is a great place for an event because it's in the middle of Washington. So no matter where you are in Washington, right, you can come converge on us. And we do have hotel rooms and dorm rooms for teams that are traveling more than 150 miles. We're booking all accommodations, and you will hear from these ladies after you register during the March 15th submission deadline. Okay. There is an event in North Carolina as well. This is another science activation partner that NESB has. This is going to be at actually an elementary school, Smoky Mountain Elementary School, which is in Whittier, North Carolina. This event is on April 29th. There will be, for teams, if you want to travel a long distance for this event, there will be hotel rooms available. And again, it's another situation where you'll be invited after the March 15th submission deadline. Okay, what was the last one? No, we got a couple more. Next, we have Arizona. Arizona is hosted by Northern Arizona University, and their event is on June 1st, with some optional events on May 31st. This is actually a combined event. They like to combine it with a robotics event that they already do. So you can sign up through their robotics newsletter. So if you are an Arizona team, you can actually use this QR code to go to that website now and sign up for that newsletter to get a little bit more information. And if you can't, if that QR code doesn't work for you, you need more information, you can email Ann Hamlet or Stephanie Jackson from Northern Arizona University. Okay. Last but not least is Idaho, and Susan Stauffer is actually here from Idaho, the contact. So if you have questions, she might be able to answer them in real time in a bit. There's 2 events in Idaho because it's a really long state and it takes a long time to drive from northern Idaho to southern Idaho and vice versa. So there's an event on April 27th in Moscow, Idaho, and there's an event on April 13th at Twin Falls. Teams only should go to one. Don't plan on going to both. That would be overkill. And they're at University of Idaho and the College of Southern Idaho. Again, another opportunity for travel support if you are driving a long distance, and you'll hear more after the March 15th deadline. Okay, so we talked a lot about this March 15th deadline. What am I referring to? What I'm referring to is the Lunar Flyby submission. This is the next opportunity to submit results for your team, but it's also required if you want to come to one of these in-person events. We need to know who's coming in order to do our event planning. So we're asking all teams that are coming to register when they make this submission. Okay, and in fact, if you don't register, you won't be able to attend because we need to make travel accommodations and things like that.
Actually, Darcy, we have a question regarding the MOs for Lunar Flyby. Can you count MO1, which is your MDL, as one of the 3 additional MOs that are needed?
I would normally say no, but if you feel like you need to, that's fine. Yes, you can.
And also,
Kind of a freebie though.
also, they wanted to know, I
Yeah.
answered in the chat, but I make sure anybody
Yeah.
else, they wanted to know if you're, if you had to complete all of the MOs to come to an in-person.
No.
And 2, do you have to have your MOs completed to submit for Lunar Flyby?
So yeah, those are great questions. I will talk again about them, but the quick answer is no, you definitely do not have to complete all mission objectives to come to an in-person event, and certainly not to fill out this form. In fact, even to do the challenge at all, you don't have to do all the mission objectives. And I know that sounds wishy-washy, but we know that some teachers and educators and students are busier than others. Okay, so no, you do not have to complete all the mission objectives. And even the 3 that you select in this form and you want us to just verify that you did them, you don't have to have those completely finished either. The intent here really is just to make sure that we are inviting teams to these events that are actively participating in the challenge. So we want to see evidence that your team is working towards completing the challenge so that when they show up, they can have a meaningful experience at the events. They're not showing up kind of without any preparation at all. Okay. So hopefully that answers the question. If it doesn't, feel free to put more in the chat.
Thank
March
you.
15th. Oh, Gary, yeah. Okay. So let's talk a little bit about this form, because there's always lots of form questions when we put one of these up. So the Lunar Flyby submission is what it's called. It's currently open on our website. And what you need to know before you fill out the form is your team numbers and names. Okay. So if you did the injection burn, you found your team numbers, which were emailed to you after you registered your teams. And then your students came up with a name. So if you did the injection burn, you should have gotten an email back, and check your spam if you didn't get it, that has the team numbers and names, because you're going to need to know that when you do this form. And in particular, we print out certificates, so we put the name of the team on those, so that's important for us to have. You need to know, obviously, if you want to go to an in-person final challenge event. So if you need to review the slides, you can do that. There's a link before you fill out the form, and you can make a decision, talk to the team, talk to the parents. And then you need to decide how you might want to consolidate students into fewer teams if needed. So it's fairly common that mission advisors will sign up 5 teams, and then a couple months down the road or a month down the road, they figure out some students don't want to do it or can't do it. So they really want to consolidate their students down to just a fewer teams, so 1 team or 2 teams. You can do that at this stage. Just figure out which teams you want to keep, the numbers and the names, and then which students are in which teams, so you can put that correctly into this form. Last but not least is, and I know this is ruly, but this is just required by our university, and it's required by the other universities as well. It's a liability risk to bring students onto campus. So we do require that all the teams coming to an in-person event have to have completed those risk and release forms, which were part of the injection burn as well. All right, so there's a video online. I'm not going to play this now, but if you missed this, there's a video online to help you fill out this form, just to give you a preview. We're just going to quickly go through what it looks like so you guys know what to do to prepare for it. Not the video though, let me skip that. The first page of the form is just your information and the team information. So team number, team name, mission advisor information. The main thing I want to emphasize here is if you have multiple teams, I know it's extra work, but you do have to click through and fill out this form for every team. Okay, so just reload it and fill it out fresh for each team. So step 2 is the evidence that the students have started work on the challenge. What we're asking you to do is take their mission development log, which should either be a Google Slides, or maybe they're working in PowerPoint or Keynote if they're crazy, okay? And just save it as a PDF. So either save it or download it as a PDF. If you can, it's nice to go in there and just delete the extra slides. If you don't do that, we'll survive. But the main thing is it does have to be less than 10 megabytes, or else we can't upload it into our form. So just take a look at the size of the file after you've saved it as a PDF. And if it's too big, do try to go in and just delete some of the extra slides if they're from mission objectives that aren't done yet or haven't been started. Or if you've got really large, a lot of images in there, just go in and maybe delete some of the images. And then we just ask you that you click and let us know which mission objectives you want us to look at. Teams should be using the provided MDL template. We've tried to simplify it this year and just give you a template, but that does not need to be complete. Okay, so this goes to Deanna's question. This is an in-progress MDL, so don't spend a lot of time making it pretty complete. It's just show us that you've been working on it. Okay. And then next, you'll just let us know, are you going to come to a in-person event? If the answer is no, you're basically done with this form. Okay, the next page will be like, great, you submitted the form. That's easy. Okay, if the answer is yes, you have a little bit more work to do. Okay, so let's say the answer is yes. You're going to let us know what event you want to come to. And every team is just going to come to one event. So select the one that is closest to you. That's what most teams are going to do. If you got 2 that are kind of equidistant, pick the one that works best for your team. Let us know if you would like to apply for travel support. So this is overnight accommodation or a mileage reimbursement for the driving time. If you click no, you won't have an opportunity to let us know that you want travel support. So please click yes if that's something that you want to do. If you click yes, we're just going to ask where you're driving from, because most of the travel support is dependent on the distance traveled. So just let us know probably the address of the school that you'll be leaving from or organization. And then here we give you an open field just to let us know anything specific about your needs. So this could include like anything specific about vehicles. Maybe you need to have a bus or something like that. Or if you think your team has a particularly high need for support, let us know. We may not be able to give equal amounts of supports or full support for every single team. You might have a team that doesn't need as much support. You're like, we're fine with the mileage. We don't need any support on that. But if we can get hotel accommodations, that would be great. So just give us something specific there about your team. And next, we need to know who's coming. So the first is the adult. if you have one team with one mission advisor, this should be the mission advisor. Mission advisors should travel with their team to the in-person event. So just fill out your information there. We're going to ask if you need overnight accommodation and if you've had a background check. Places like Central Washington University require all adults traveling with minors to have a background check. It's in Washington state law. So a lot of the mission advisors are educators, so teachers, so that's not a problem, but please indicate that. If you're a mission advisor that has a lot of teams, like 8 teams, right? One adult supervising, 8 teams worth of students is not enough. So you can add additional adults in for those other teams. You should be the adult for one of the teams, but the other teams can have other adult supervisors. We may need to background check those adults, so give them a heads up on that. It will be at no cost to them, but they'll have to go fill out information. We'll process the background check so that they can travel with the students. Okay, student participant information. How many students are on the team? What are their names? This is the name that's going to be on their name tag and on their certificate. Whether or not they're attending the event. So if you have a student team member that's not attending, but the rest of the team is, we still want to know their name so we can put it on their certificate and we can give that to you to give to them when you get home. Obviously, if they are attending the event, just say yes. If they need overnight accommodation, say yes. And in that case, we will ask for their age and their gender so that we can appropriately separate students out in rooms. Okay. Lots of information. And then because it's the event, we need to know allergies and gluten sensitivity and ADA stuff. All right. I know that's a lot of boring stuff, but that's what the form looks like. When you're done, you don't forget to hit submit. So you see this screen, it gives you a preview of everything so you can go back and change it. You got one more step, hit submit. And you should see the green screen. The green screen means you've completed the form. If you have to do it for another team, just reload the URL and the form will show up blank again, and you can refill it out for an additional team. Okay, I'm going to take a break there and ask if there's any questions about this submission.
We've got a couple in the chat that I was about to respond to, so this is perfect timing.
Okay.
So we've got one question, can the parents accompany if they pay their way? The person is not sure if parents would feel comfortable with just them and the group of students.
Mm-hmm.
But I also have a policy to have 2 adults, for my own liability purposes.
Yeah.
So do you want to answer that or do you want me to answer it?
Why did you answer it?
Okay, so I'm going to tell you the information at Central. Each center has a slightly different ruling, which is or governance. So that's why we're having you contact the individual programs, or they will be in contact with you to discuss your individual situation. But here at Central, if you are a mission advisor for, let's start with the easy one team, we are expecting that you and your team will come across. If parents want to drive on their own, they can. If you are coming from Seattle or Bellingham or let's pick on Walla Walla on the other end of the state, you're more than likely going to need to stay overnight with us. We will provide those accommodations for the team and for the mission advisor.
Mm-hmm.
So I hope that answers your question regarding Washington State.
Mm-hmm.
And remember, Oregon is coming to Washington also. So that's going to be pretty much the guiding principles here in Washington. Each hub coordinator will be in contact with you. Put your little information in that box and they will go over your individual situation with you. Brent messaged, sorry, if you cannot attend the in-person event, can you turn the lunar flyby later than March? Brent, there are 500 teams and there's 4 of us. So please, the lunar flyby is a hard date. We need to know what you're working on because it helps us with the final challenge. But even if you're not going to attend a in-person, if you're submitting for lunar flyby, please submit by March 15th. There's only 4 of us. That's it. And there's 500 teams. So the math is not in our favor. So when you turn things in on time, we're able to turn things around. And I
And can I
understand,
add to that, Deanna?
go ahead.
We're actually, again, we're always fighting confusion on this side. We try to be flexible because that is what helps us reach a lot of students and educators, but flexibility leads to confusion. So one thing, Matt, that we do is we only have one form up at a time. So that's another reason why we don't allow late submissions, because if we had, you know, the injection burn and lunar flyby forms open at the same time, it would be very confusing for people about which form to fill out. So that's why we take forms down at a certain time, and so we can put the next one up.
And Brent,
yeah.
please keep in mind with this, it's not completed. It's just in
Mhm.
progress.
Yes.
So if that helps, because you only meet once a week or once every other week, we just need to see what your progress is.
Yep.
So please, if you can, just show us what you've got.
Yep.
Evelyn wants to know, is there a YouTube on the robot missions our kiddos can watch? We have some programming on our YouTube channel. I'll drop it in the chat, and it'll go to everyone in just a few minutes. Doug Bailey, can we get a list of food allergies sent to us so we can get the info from students ahead of time? Doug, because there's so many students, please just list on there what your student allergies are.
Mhm.
There's too many programs and way too many food allergies to try to narrow that down.
Mhm.
Let's see. My team is made up of 4 girls and 1 boy. Can I have a female parent join me as a chaperone to be reimbursed for expenses? I'm in Montana. Leslie, please put that in your information for Montana, and the individual hub coordinator for that information will be there.
Yeah,
Amy,
and let me just add, Deanna, sorry, but this last page of the form, it talks about, and I can maybe add a little bit of text in here. It's mostly about allergies and things, but there is an open field here where you could put that in there if you need to. So put that information. I need to bring another adult because my school requires 1 of each gender. And frankly, if you're coming for an overnight, that's tricky too, because we can't have obviously adults of other genders in rooms with minors, all kinds of things. It's complicated, but yeah, go ahead, Deanna, more questions.
oh yeah, lots more questions. So
Yeah.
hold on, I'm dropping our YouTube in.
Okay, I'm gonna address a couple. So basically a lot of these are like, what if we need to bring more adults? If that's true, then go ahead and put the thing in there. I'm not gonna guarantee that we can offer travel support for lots of additional adults, especially if they're just parents. I would assume if it's just parents that are not required to travel with the team because of a school policy, they probably will have to fund their own travel. But if there are cases where you need another adult due to a school policy, that could be something that individual hub events could support. So just put that in there. And then Susan asked me to address what about if injection burn wasn't completed? So what if your team did not complete the last submission with a mission patch? If they didn't, but they still want to come to an in-person event, please just go fill out this form, okay? And we will proceed with your team. We might need to ask you to collect those risk and release forms before you travel to the event. But don't not fill out this and register for an event just because you didn't do that submission. Okay.
We had a question that wants to know what the final submission date is. I am going to say, please read the manual. And I'm not going to give the date here because you can go to the website and get the manual. Please, you guys, I have the manual, and I know you're probably saying, yeah, well, you get paid to have the manual. I have the manual within arm's reach at all times because questions come up, fine points come up, dates come up, and people want to know. And you can flip to page 4 of the manual and find out the exact answer to that question immediately. So please check the manual. And I'll drop the link down in the chat. So thank you very much. But please read the manual.
Yeah. All right.
Evelyn's got a question. If we bring teams for both sessions in Arizona, is there funding to help with the Invitational and Artemis Roads? Arizona only has one event.
Yeah, I think they're going to be at the same time. So that those 2 events are concurrent. So you probably don't need 2 sets of travel support, but that's something to ask Anne. Because if you're doing the invitational, we don't know anything about that or how it's supported. Gary, you have a question?
Yep,
And
thanks.
you may have already answered it. I've had my volume off and on.
Okay,
So March 15th, according to my calendar, and I know I live on a reservation, is a Friday.
uh-huh.
And all the papers say, including page 4, the manual says
Oh.
Wednesday.
Does it say it's not a Friday, it's a Wednesday?
Yeah,
Oh,
Well, we make mistakes too.
I know, yeah, so what is it?
it's the 15th.
It's the 15th.
Okay, all right, thank you
Let me
both.
tell you what happened, Gary. When we made that manual, and by we, I mean myself, I think I was looking at a 2003 calendar.
Yeah, or, yeah, maybe even 3,000.
No,
Okay.
I thought I tracked down all those mistakes, but it was a moment where I caught myself. Okay,
All right, thank you
let's
both.
keep going, but that's a good point. I just thought you were going to complain that it was a Friday, so I was going to say, you don't have to do it on the Friday, just like,
Oh.
yeah.
Yeah, I thought that's where we was going to. We have another question. If
Okay.
not staying overnight, do you need 1 adult per team? The mission advisor needs to travel with the team. That's number 1.
Mhm.
And you should probably, if you're not staying overnight, then no, but please, for your individual hub event, contact your individual hub coordinator.
Mhm.
Here at Central, the answer, again, this is Central, the answer would be no. However, 1 team, 1 mission advisor, 1 mission advisor, multiple teams. We need an adult for each of those additional teams. So please contact the mission advisor and give them your specifics.
Yeah,
Okay.
and the teams are going to be, depending on the event, they may need to navigate around a college campus a little bit. So if they're middle school students, you might just get a bunch of lost kids if they don't have an adult traveling with them. So
There's another question about how late will the form be up on March 15th? It's in the manual, but since we discovered that we had the wrong day of the week
Yes,
for the
right.
manual, I'll give out, it's 5 p.m.
Yeah.
Please, I would like to go home on the weekend and rest. So please submit beforehand. I can't support you if I'm not here, if you run into submission problems. So please, 5 p.m. by our time. Pacific.
Okay. And I'm going to keep going. We'll
Yep,
have
no,
more
we
time for questions at the end, but this is, I don't want to spend too much time in the middle of this. Okay. So very quick. So what means if you can't attend an in-person event? So lots of teams, like I said, are not close to one of these events. That's totally fine. Okay. Filling out that form is a lot quicker, but we do have an option to submit the final challenge results. So basically show us the same kind of things that the students would be demonstrating at an in-person event in a video, and you will upload that online. Okay. Teams submitting virtually will still receive certificates of completion, and they are still eligible to receive the trip to the Kennedy Space Center. So again, if you choose to not go to an in-person event, if it doesn't work for you and your students, or if you're too far away, go ahead and do the B version of Mission Objective 8. Okay, so I want to take a little pause here. We're going to switch gears a little bit. That's logistics. This is still logistics, but a little bit more of the educational side of it. And I'm going to talk about a couple of the mission objectives. These are ones that we're hoping the teams can demonstrate when they come to an in-person event or demonstrate in their video. Okay, so I'm not going to go through them in a lot of detail, but I'll talk a little bit about them, and then we can have time for questions. So mission objective 3 is called Getting to the Moon. It's the water bottle rocket one. And it's the idea, the point of it is to get students thinking about this part of the Artemis mission, which is a massive part of the Artemis mission, safely developing and designing a new rocket that can take astronauts back to the moon and then eventually to Mars, okay? And then how NASA goes through that. So if you look in the lesson that's accompanied with the mission objective, you can learn a little bit about NASA's SLS rocket. I'm not going to talk about it too much here, but I would encourage you, if you're working with your students, to have them look at it, talk about it. You can, if you know a little bit about the space shuttle, you can kind of maybe talk to them a little bit about how the components of the space shuttle were modified to make this rocket. And then you want to get them to think about the engineering design process. So fundamentally, what this mission objective is about is this idea that when you are an engineer, your first idea is not the final idea, okay? You really do have to collaborate with your teammates to address a question, brainstorm, come up with solutions, right? Create your design or your solution, and then test it. And you're going to find when you test it that it's not perfect, okay? So you're going to improve it, and then you're going to test it again, and you're going to continue to go along in this cycle until you feel like you have a solution that works good enough for what you need it to do. Okay, so that's the point, is to make sure that students aren't just building one rocket and launching it and saying, that's good. Have them launch it and say, hey, like what went well, what could have gone better? How do you think you can improve your design? So I'm talking a little bit about rocketry here, not too much, okay, but just two important concepts that will help your students understand how to design a good rocket, okay? So if you guys did the PD with me, you've seen this before. You don't really have to do it, but if you want, you can find something around you, preferably something that, like a pen is pretty boring, but something that's kind of long and skinny, like a ruler or a brush or a kitchen thing, and toss it in the air. And then observe how it basically, toss it with a little bit of rotation, and then observe how it rotates, okay? So I'm going to keep going just for time, but this is something you could demonstrate with your students. And then I really like playing this video, except for it's not working on this. Let's see. Can you guys see it in the new screen? Deanna, can you see the video?
Yes, I'm sorry. I thought I was muted. Yes.
Okay. I'm just going to leave this here, so ignore what's on the side here. But this is a nice video that shows the same thing that you can show to students. So here's a physics professor, and he is just tossing a bunch of stuff, okay? And then he turns off the lights, and he's put a sticker, a fluorescent sticker, on what's called the center of mass of those same objects, okay? And he's going to toss the same objects across the room with a little bit of rotation in the same way. And what you can see or demonstrate to your students is when you do that, you actually, it just looks like a ball, right, is going across the room. You don't see any of the rotation at all because the sticker they put on that object is not rotating. The rest of the object is rotating around that sticker. Okay. I'll turn on the lights here at the end of the video so you can, they don't for this one. Let me go back here. Okay, again, it's the same objects they were throwing before. Okay. And what you should notice, by the way, about the objects, let's look back at this one. Not that one, let's see. The long, skinny one. Is that it rotates closer to where the mass is, okay? All right, so let me go back to this, the slides here. Go forward, maybe, okay. And what we're trying to teach them about is this idea that rockets basically, as they're flying through the air, if they're gonna start to rotate, they're gonna start to rotate about that center of mass. So the center of mass is literally where you would balance the rocket. If you could balance it on your finger, it is the average position of the mass. So this is a slide that's borrowed from the companion course lesson that's associated with the mission objective. And this is something you can build with your students if you have time. It's called a stick rocket. It's got fins on it. And basically what this demonstrates is how you can add fins to a rocket, which is going to affect something called the center of pressure to stabilize the rocket, okay? So the center of pressure is like the center of mass. The center of mass is the average location of the mass. The center of pressure is the average location of the cross-sectional surface area of a rocket. Okay, so when I add fins to a rocket, basically I am moving the center of pressure closer to where the fins are, or usually closer to the bottom of the rocket. And hopefully this video will work. Again, this is all in the companion course lesson. If you have a stable rocket, you should be able to attach a string to the center of mass and then rotate it around like this. And the fins will actually stabilize the rocket and cause it not to tumble. That's why we add fins, okay? So let's think about that a little bit with these 3 rockets, okay? So these are 3 different rockets that have their center of mass in red, also called the center of gravity, labeled. So that's the location of the average mass of the rocket, okay? It's usually right in the middle. And then the center of pressure is also labeled as green, and that's closer to where the average area is. So if it's got big fins on the bottom, it's going to be closer to the bottom. It's like this 3rd rocket, and it's got fins in the middle, and on the top, it's going to be closer to the top, okay? So I want you guys to tell me, which rocket do you think is going to be the most successful in flight?
The first one.
The first one, okay. Anybody else? Why do you think the first one? Let me know.
Center of pressure is behind the center of gravity.
Okay, so what does that do for the rocket? What does it do if the center of pressure is lower than the center of mass or center of gravity? Does anybody
Makes a stable flight.
Yeah, it makes a stable flight. You're right. Okay. I just want to, and again, it's just useful for students to understand this because this is the main part that's going to help them build a successful rocket. I want you to think about these 3 rockets flying and getting hit by a gust of wind, or maybe their engines don't fire exactly perfectly, okay? It's going to start to rotate. And so imagine, let's go ahead and imagine the 3rd rocket starting to rotate around the red point, the center of mass. That rocket's still going up, okay? It's going to rotate around that red point around the center of mass because its center of pressure or its fins are up here above it. All that air is going to be pushing on the fins above that center of mass, and that rocket's going to keep rotating in the same direction, okay? If the fins are down here, if the rocket starts rotating this way, the force on the fins is going to be over here and it's going to restabilize the rocket. Okay, so that's the main thing you really want students to understand about rocketry. And I know I don't want to do a whole lesson, I kind of did on it, but that's the thing that if you guys understand that, you can help your students understand that, and that can help them understand how to build a stable rocket, okay? So let's talk about the deliverables. So what do they have to do to complete this MDL? They need to have at least 2 different rocket designs to compare. They can do more if you have time and they want to do more. Because safety is important when you're dealing even with these water bottle rockets, we're asking them to think about safety. The best way to be safe is to think about it before you're in a dangerous situation. So that's why we're asking for them to do a safety checklist, procedures, and protocols. And then they have to analyze their flight. So basically, this is that engineering design process. Test and analyze the quality of the rocket flight so that they can improve it. So hopefully if they have 2 designs, the second design is an improvement on the first one. Okay, how they analyze the rocket flights depends on their age, basically. So we do have this grade level adaptation. So if they're just 3 through 5 upper elementary, they can just use a qualitative analysis like, you know, this rocket tumbled and the other one flew straight. This rocket went higher than the other one. That's fine for the young guys. The older students, middle school, needs to have some kind of qualitative analysis, okay? So we did give you guys a means for measuring how high the rockets went with the altitude tracker. So they can say like this rocket flew to 50 feet and the other one flew 70 feet. Okay, and then stability is hard to quantify. We give you, there is a sheet on there that has like a stability scale, but they should do something to be more precise about stability. And then sturdiness is literally like when the rocket hit the ground, did a fin fall off, you know, how reliable, reusable is their design. And then because they're middle school and they should be learning this, they should do some statistical analysis. So that means that they should fly each design more than one time because you guys know those rocket launchers aren't perfect. So getting a statistical number of flights for each rocket will make the comparison more meaningful. The only thing we're asking the older students to do in addition is to do a table or a graph, so just a more sophisticated presentation of the same type of data. I think that's, oh, no, it's not. Okay, so some resources. If you got the Aquapod rocket thing, the launcher, and you're not sure what to do with it, I just want to remind you guys there is a tutorial video you can link to. It's in the resources. You can find the resources at the bottom of the mission objective, but you can also find it on our website. There's an Artemis Roads 2 resources and frequently asked questions. This has all the links that are in the manual. So you can go there as well. So I'm not going to play the tutorial, but it's a pretty short video. It's appropriate for students to watch to help you use that launcher and launch your rocket. If you want to build your own rocket launcher, which is a great thing to do, it's a great thing to have as an educator, there is directions from NASA. You can find other ones online too about how to build a launcher that could work with a water bottle. And then another link is another NASA resource that talks about the flight of a water bottle rocket. And this link will help with talking about some of the jargon, like apogee and things like that, powered ascent, coasting ascent, just kind of going through what happens, the physics of the flight of a rocket. It's not very detailed, this particular link. They've been updating this website a lot, but it can be a helpful resource for the students. What is included in this link, which actually is kind of frustrating for me because I knew this simulation existed, but I could not find it when I was writing this mission objective, is there is actually now a working simulator on this website. So that third link. So it's still a kind of a complicated simulator to use for younger students, but if you want them to model their rocket designs or different rocket designs on a computer and simulate the flight, you can use this simulator that has been adapted to work in modern browsers. Okay, so that's now available, which is great because it's easier to use than the fourth link here that I provided for you guys, which is using OpenRocket to simulate a water bottle rocket. OpenRocket is a great program if you guys haven't played with it. It's definitely for older students, so like high school age, I would say, and it's not made for water bottle rockets. So basically we did some modifications so you could use it with water bottle rockets, but if you have younger students, I recommend using this other simulator if you're going to do that. Okay, that's what I have on rockets. So I'm just going to give you guys a couple of minutes for questions. And then if there's a lot of questions, I might have you hold off to the end. I'll look at the chat. Go ahead.
We've already actually got one of them, and
Okay.
they want to know if they can use a solid engine, good Lord, engine
Mhm.
Etsy type rocket as their second rocket.
That's, I mean, that's really comparing apples and oranges right there. I would say not to complete this mission objective. That's not to discourage the students from launching a solid rocket engine. But that is not what we're asking them to do here. We're asking them to make more subtle designs. I mean, obviously, if I went from like an Estes rocket to like a liquid engine rocket, I would get a better rocket flight or a higher rocket flight. We're kind of looking for more subtle things like what happens if I change the fin design or something like that. So ask your students to change their water bottle rocket. And then after they're done, reward them with the Estes rocket launch.
Doug has made a comment that he had a terrible time launching with the Aquapods.
Yeah.
It takes a little bit of finesse to get them. I highly recommend you start off on cement if possible, and then move to a lawn if you're going to do that. And
Yeah.
Doug has his hand raised also.
The Aquapod launchers, we looked for a launcher that we could easily provide. There's not a lot of pre-assembled water bottle rocket launchers, and we did not want to send you guys a box of parts that you would have to build your own water bottle rocket launcher out of. So what I would say, Doug, too, if you're dissatisfied with it, and I totally understand they don't go up to the pressure that they say they will, depending on the launcher, and you have the time and energy, build your own. I mean, I know there's probably lots of educators here that have their own and then built it. You use them for decades. Like they last and they're great, and they're better quality, the ones that you build yourself. What's the next question?
We had a group who created their own rocket fuel outside of class and wanted to bring it to school to test to launch it. That would not be allowed to come to Central, but you're welcome to do that at your school if you'd
Yeah.
like to. Professor Snowden, what are your thoughts on that?
So, oh gosh, I mean, I can't say specifically, you're the best person that knows. I mean, I don't even know what kind of fuel they made. This is what I tell my students, because I've been in that very similar place where I've had a research student want to make their own solid rocket fuel. There is a subtle difference between a rocket and a bomb. It's extremely subtle. So you need to use your best judgment. You need to make sure that they are being safe. It seems like these water bottle rockets can't hurt you, but they can, okay? Especially if they are coming off the launch pad at unexpected times, at pressures that are lower than you think. So there are lots of examples online about people using soda or something like that in the launchers. That's probably okay. It's just sticky and gross, to be quite honest. But if it's something more dangerous than that, yeah, I don't know. I can't say without knowing the specifics.
Our bottle rockets inspired them was the to do something and to explore was the comment that came after that.
That's
So
great. I mean, I would encourage
information,
creativity, but it's hard. Yeah. It goes very quickly to fire and it comes with young students. I would know that very well. Any
I
other
don't have
questions?
more questions on this side.
Okay, yeah, I don't have any over here. Okay, so I hope that was helpful. Again, don't hesitate to reach out if you have questions via email. And it's not going to be perfect. So it's about them exploring and discovering. And if they're inspired to do other types of rocketry, amazing. Because it's so much fun and they learn a lot from it. Okay. So the other one that's tricky is this roving on the moon. It's the robotics one. There's always a robotics one in these Rhodes challenges. That's what the R stands for. And in this case, it's coming at the end here. And this is one that's always going to take your team quite a bit of time to do, especially if they don't have any experience at all with programming or robotics. So the main thing I want to emphasize here is this. I mean, it is a toy. Of course, it's fun. But the main thing is the Spike robots. The reason why we have them as part of the challenge is we're trying to expose students, not just to the building part of robotics, like designing the robot, but programming. Like, how do I write a full code that the robot's going to execute? So try to discourage your kids from using the Bluetooth to just make this like an RC car, because they're not learning what we want them to learn and they're not getting the experience we want them to by doing it that way. It's a little bit harder, but that's the point. Okay, so this is the challenge map. This map is available to you guys. It's linked at the bottom of the mission objective. It's linked in the resources. The point of this is they're navigating. Now we're on the moon. We have a habitat on the moon and the rover is navigating around this lunar habitat. Okay, it's going to start, I'll talk about it a little bit more, but it starts in the middle. And the point is it's going to be delivering packages to the different colored targets. Okay, just a little bit more about the map. So this map is 100 centimeters tall and 150 centimeters wide. Okay, we've gone metric. Okay, that's about almost 40 inches by 60 inches in the other way. Okay, I made it that size because it's still big enough that these robots can drive around and big enough to be interesting, but it can still be printed if you choose to print it on a large plotter. So at Central, we have these, some schools have them, Office Depot, FedEx should have a printer that can print paper rolls 48 inches wide if you choose to print it, okay? To print it, you would want to download not this presentation, go to the slide that's in that presentation as a PDF. And there's different options. I'll tell you that in a second. And just give it to the printer, tell them what size it should be, and tell them it's important that it's actually that size, right? Because sometimes they might mess up the scaling. You should make them reprint it for free for you if they mess up the scaling. So after they print it, just verify that the scaling is correct by measuring one of the obstacles. So for example, you could measure the box underneath the rocket here and just make sure it's 10 centimeters by 20 centimeters. They should be able to print it exactly to scale. There's different, especially if you're printing it at your school, they might gasp at the amount of toner that would take. So there's different versions of it so that you can go easy on the toner. And there's also a version of it with gridding so that students can use the grid to help them figure out how far to drive their robot and when to turn it. Okay. On this map, and I think this is another little bit of a mistake I have to admit to, that it's not very explicit in the manual. They should be avoiding the magenta regions, okay? So that gives them a challenge of having to drive around, so they're not running into the solar panels and the rocket and going into these other craters and things like that. So try to have the students avoid the magenta regions as they're heading towards the colored targets. If you do not want to print the map, okay, you don't want to spend the money to print it, you can make your own map, okay? So if you have large rolls of paper, you can use those and students can literally just draw on the paper what the boundary is. They can use foam board as well, or we've had students use just masking tape on the floor to come up with the boundaries of the map. And then they can choose to also just draw the obstacles, or we've provided basically a document that has all the targets in just regular printer paper. So that you can print out those targets. All those targets will be the right size so that students can cut them out and place them in the right positions on their homemade map, okay? To figure out the right positions, go to the second link here, which gives the coordinates of each of those particular objects on the map. And of course, when they're done, they can compare it to this picture to make sure it looks right. Okay, so those are the options for making the map. Give you a couple, you only have to do one, okay? When you come to an in-person event, the map will be there. So you don't have to bring whatever map your students made. We'll have a map provided for you. Okay, so what is the challenge? The challenge is the robots are going to start right here in the middle, the gray crosshairs. The students can place the robot there, and then they have to have some means of carrying a package. It could look like a dumpster truck. It could look like a grabber. It could be a pusher. Okay, whatever you want, your students want to do. But wherever that thing is that's carrying the package, it also needs to have a way of sensing the color of the package. Okay, so let's imagine in a scenario where they do a dumpster truck or something like that. I'm going to put the package in the rover, and there will be the color sensor positioned correctly to say, this is a green package. Okay, the robot says that's a green package. Green packages go to the Earth Communication Outpost or the green target. Okay, so then the rover, after sensing the color, maybe it has a little bit of a timer, a weight on it, it drives to the green target and it drops off the package. And the goal would be to drop it off as close to the center of the target as possible. After dropping off the package, the robot should drive back to the start, okay? At this point, we're gonna try to load another package onto the robot so it can test its logic and go to another location. Same protocol. In an in-person event, and when you do this with your students, if you're doing a video, it's very likely that the robot's probably not going to get exactly back to the start position. So we're probably going to let them nudge it back in there so it's starting exactly where they think it's going to start every time. Okay, so there can be a little bit of a hand assist there, but if the team can do it perfectly, that would be amazing too. Okay, so to help the students, there's grade level handouts that are appropriate for the students to read and learn about the challenge. Those are linked at the bottom of this mission objective. So if you want to print those off, give those to the students. They can read about it in order to what they need to do themselves, okay? Again, these are the resources that are at the end of the mission objective and on the resources page. So Deanna put the link in the chat already, but there is a couple of YouTube videos that help them understand how to program the robot, including a special one that's just on MyBlocks, which is a type of programming thing that we're going to ask them, the older students, to do. There's a link to the map. That's what I showed you. And the map has more description on it about how to print it, the different versions, how to make it yourself if you want, the student handouts for different age ranges. The sample square cutouts, this is just another thing you can print out and have the students cut out little inch by inch square packages that are the right color that they can use to test their robot, and then links to the companion course. And this is another math exercise. Okay, and again, I just want to talk about the companion course. If your students have no experience with robotics, going into the companion course will be helpful because we have some easier challenges for them to start with, like drawing or like programming a robot to drive along a yellow line like this. That will hopefully get them on board with programming before they take on the full mission objective. Okay, so what are the deliverables? To complete this mission objective, all students have to include a picture, so just a camera picture or a drawing of their rover, labeling the important components so we can understand why they designed it the way they did. And then they have to describe the path their rover travels by drawing a coordinate system in the MDL that includes an origin, which can be at the start point, ticks or a grid measure in centimeters, and then the location of the supply drop locations, and then the path that their robot is going to follow. Okay, so this is part of the planning of programming. They should have maybe designed what this path was before they ever programmed it to begin with. So we want to see that they actually thought about how their rover is going to navigate on the map. Okay, and if you have younger students, allow them to use the gridded version if you can print it out, because that'll help actually them do this coordinate system. The grade levels are, if you're middle school or older, we ask that the students include a MyBlock, or if they're programming in Python, which you can do with the spikes, a function. These are ways you can combine basically repeated code into a smaller custom word block, so that their code is more readable. Again, there's a video that will help them do that. This is going to help them understand an important programming structure. For these older students, we're going to have them scale up their map. So their rover's driving on this little map. So we're going to ask them to scale it up to how far that would be on the actual moon. Okay, so they can figure out how far would this mean if I was actually driving these distances on the moon. And then doing just a little bit of math, they'll figure out how many trips a real lunar rover could complete without needing a recharge. Okay, so just a little bit of a math challenge for them. If they're in 9th through 12th, we're going to ask they include a flow chart, which is another coding structure. And this is, again, we do this because these are in the national, the NGSS standards for the students in these age range. Okay. So there's a question in the chat. I'm ready for questions. That's the last slide.
You got a bunch of them. I was
okay, good.
like,
I only
read
see a
them all.
couple. I think they're sending them all to you, which is fine.
yeah.
I'll
So-
answer the ones that I see. So you see one from Michelle. Can they change starting direction per color or always start facing the same way? I'm going to say they should plan on always facing the same way because they don't know what color package is going to be put in their robot. So if they need to be facing this way for a green package and that way for a red package, that's going to screw them up. So tell them they should always plan on starting the same way. And if they then want to do 180-degree turn because it's a green package right away, that's fine. All right, what's next?
Okay, hold on. I was typing. So, okay, you got that one.
Yeah.
What would be the size and scale of the map at the in-person challenge? I started to answer this,
Oh,
but
same
Yep.
as the 100 centimeters by 150, which is
okay.
really important because we don't want students to come to basically they should, if they program their robot well, it should work at the in-person event just like it works at home. So same scale.
And then there's a question is where does the rover start? And that I typed part of it, but didn't get to all of it. That's
Right
the
here,
gray
this
circle
gray thing in the middle, right in the middle,
Okay,
right by the main habitat.
that's where your robot starts.
Yep.
Okay, hang on, let me see if I got through all of them.
And the reason why that's like a hashtag is it's helpful for them to line it up right if they've got some lines on there to help them line their robot up perfectly. I see Cindy, do you want to ask your question? You see a hand up?
Oh, you've got two hands up. Oh, and
Yep.
Gary, I think, has been up for a little bit. I'm sorry.
Yeah.
Yeah.
Okay.
I can ask mine. I just have a question about the packages. So do they start? I guess I'm just confused with how the package gets on the rover. So do we physically place it on the rover,
Yeah,
or does that also have to be done by the rover?
No, so once it's so imagine like you're an astronaut living in the main habitat.
Okay.
You're gonna go
Mhm.
outside and put it and so what that means, so I gave the dump truck example where I'm imagining
Okay.
actually putting it in, but if they're a grabbing robot, then maybe you help them grab it or something like that. That's fine too, or put it in front of the pusher.
Okay,
Yeah.
and then are those parts in the spike box, so we don't need any additional pieces to make that that like dump truck part or the part that's going to take it from the rover and place it on?
Yeah, so they're gonna have to get creative with their
Okay.
design.
Okay.
And so, yeah.
So
There
that
are
probably
some-
takes a long time then, I would think, like for some of
Yeah.
them, but maybe some of them that's quick. It just depends how much
Yeah,
Legos, but
what I
okay.
would, and you can, you have a team of students, so there is also the option to divide and conquer.
Okay.
Some students might be more interested in the programming and want to focus in on that, and other students might want to focus in on the Legos part, the building part. But they're
Okay.
kids, they do like Legos, and you'd be surprised
Yeah.
how quickly you can come up with because there's an
Okay.
extra motor in the kit, and the extra motor can be used for grabbing
Oh.
mechanisms or dumping mechanisms, and then there's 2 motors for the wheels.
Okay, that's helpful to think about them saying like you're the astronaut placing this on the rover.
Yeah, that would be
I
hard if
wasn't
they had to
sure.
like go pick it up. Yeah, so we give
Yeah.
them a little bit of help there, and you would expect, especially if they're new, there might be some nudging. So
Okay.
like I said, getting it to go exactly back to where it started and ready to go again, that's,
So could you even add weight then to that? I know you have like the cutouts and we did them, but they're like paper. So could you even add weight to those packages if that like helped get it from the rover onto the thing?
yeah, you can add weight for sure.
Okay.
Yeah, and you
Okay,
could,
cool.
yeah, you can, and if you want, if those aren't working well for you, you can make, you can just make you could take the Lego blocks out of the kit. and
Oh,
use
great,
those
great.
too.
Perfect.
What we're gonna have
Okay.
at the in-person event are like foam blocks.
Mhm.
So they'll have a little, they're not heavy, but they'll be solid. Yeah.
Okay, great. Thank you so much.
Yep. Gary, do you want to go ahead and ask your question? Oh, yours muted maybe.
You're right. Okay, I know we're not supposed to drive over the magenta color.
Yeah.
So if we have a grabber and it kind of overlaps, does that count?
That's fine.
It's okay to overlap because they stick out pretty far.
Yeah, it's pretty tight to get around them. And in
Yeah.
fact, because I kind of didn't make that super clear, I'm not going to be mad if students are driving over the pink regions, but yeah, try to, yes.
Yeah.
If they overlap them a little bit, that's fine. The hardest bit is just getting to the targets. Try to not have them like go straight through the rocket.
Oh, yeah, no.
Yeah.
Okay, so you said the
Uh-huh.
rover had to be facing this, the same direction all the time, and Deanna says we can face it wherever we want.
No, well, think about the logic of the program. Does that make sense to you? Because kids don't know what color is going to be put in there. So they can face it whatever they want to start, but it should always be starting oriented the same way.
Okay,
Because the orientation cannot depend on the color because they don't know what color is going to be put in there. Does that make
but I
sense?
do,
Huh?
but I
You
do.
do. Yeah, but that's not the
No,
robot.
I know, no, I
Yeah.
know. Okay, no, that's great, thank you.
Uh-huh.
Thank you for clarifying that. I did mean your second definition.
Yeah.
Darcy. Thank you. Yeah. I'm
My
sorry.
goal with these challenges is come up with ways that they cannot use it like a remote control car.
We
Go
have a
ahead,
couple
Rachna.
other questions. Rachna has her hand. Yeah, Rachna, go for it, Rachna.
All right. I know it's been mentioned in different ways. I just want to make sure that I understand this correctly as well. So the rover needs to start somewhere in the center where the gray circle is.
Yep.
Facing in the same direction.
Yep.
And we will place different like one sample at a time for the rover to grab, and then accordingly that program should direct the rover to take it to the matching circle. And then we pick up the rover and bring it back to the gray circle.
So students should have the rover after it drops off, drive back to the start. Okay. I'm imagining for most teams, it's probably not going to drive perfectly back to the start because that's kind of a lot of driving very precisely for these robots. So you can start by moving the rover by hand back to the start if they manage to drop off the package, but the ultimate would be, the robot drops off the package and then it drives itself back to the start. and waits for
Oh,
another.
because it said like, you know, everything needs to be pre-programmed. You're not going to be able to do anything in between. But
Mhm.
when you mean pre-programmed, it's just from the gray circle to each target and back to the gray circle.
Yeah,
Like,
so
that would be a
in-
program.
In the code, there should be what's called a decision branching or logic or if statements where it says, oh, the color sensor says it's green. So in the code, there's some code that says, if the package is green, I drive, you know, this way, this way, this way, this way, drop off the package, this way, this way, this way, this way. And then it waits. Another color gets put in there. Oh, this package is blue. I go this way, this way, this way, drop off the package, and then follow, trace back to the start.
Got it. Okay.
Yeah, does that make sense? So it's
Using the
using that if
inference.
statement in there, and I can help you guys with that if you need help.
Okay.
Mhm.
All right, you have a couple questions that I
Okay.
did not get to. Rachna got her question answered. Someone wants to know, with so many teams, will each team go through all 4 packages or just the first 2 or 3 randomly placed in the cargo?
Be ready for all 4.
I knew-
It really
I
depends,
knew you would
honestly,
that
that
one.
one and in-person events, yeah, there are a lot of teams and different events may have different numbers of teams, so the decision on how many packages we put in there is gonna depend on how quickly each team has to go through the event, but yeah. I mean, it's not, the map isn't huge, and might as well test all the colors. Yeah.
So let's see. Do the kits have more than one color sensor specifically to avoid magenta areas? The kits have, your color sensor
They don't.
does, I think there's 9 different colors that the
Yeah,
Lego.
but they want to sense the color of the ground, and they also want to sense the package in another place. So they want 2 separate color sensors. So no, they don't. And I think it would be, I know that students like to do this, like sense the color of the ground and use that to navigate. My programming brain says that's going to be harder than just telling the robot exactly how far to go straight and then when to turn. You can buy an extra color sensor if that's something your team really wants to try to do, but yeah, you won't be able, unless they're really clever about their design and where the color sensor is, it would be hard to sense both the package color and the color of the ground, the surface. All right, let's see.
I think we got through all of the questions that were in here.
Okay.
Are there any other questions? Rachna, I'm still showing your hand up. Do you have
Oh,
another?
I'm sorry. I'm sorry.
Okay. No,
Okay.
it's quite all right.
Again, you guys might find questions or have questions along the way. You can send them to us via email or show up at office hours. Have patience with your students. It's okay if they don't do 100% perfect, like complete this. The idea is to try it, to get some experience. If you can figure out and talk with your students about ways to scale this, like, hey, let's learn how to drive, you know, the robot first at all, okay? Let's learn about how to use the color sensor. Okay, I've got those 2 things together. Now let's learn about how to drive to the yellow target. Okay, now let's think about how do I actually drop off a package? So they're not just like trying to do everything at once. That can overwhelm them pretty quickly. All right, but yeah, if you guys need to sign off, I know it's getting late. We'll stay on if people have more questions, but we'll end the official session there. Thank you for joining us. Don't hesitate. I'm going to the end slide here. Don't hesitate to reach out if you have more questions via email.
And I'm stopping the recording.
Okay.